Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Diels-Alder reaction. If you see the statement, 4 pi plus 2 pi cycloaddition reaction between conjugated diene and dienophile. The statement is saying that it is an example of addition reaction. In addition reactions, what we are observing, the combination of two reactants produces a single product. That is the addition reaction. But this is which kind of addition? Cycloaddition means whatever the product is formed, the product would be in a cyclic form. Cyclic compounds are observed in Diels-Alder reaction. Okay. What are the reactants here? Conjugated diene and dienophile. Conjugated diene means the alkene which is containing two pi bonds in alternative position. See this one. These are all the dienes, conjugated dienes. In all the cases, what we are observing? Alternative pi bonds or not? So these kind of compounds will be involved in the Diels-Alder reaction. Then what is the dienophile? The dienophile where we are having pi bond. Simply people are calling it as a alkene. But here what should we do? We need to create the electron deficiency at the alkene. So how can we create the electron deficiency at the pi bond? By placing some electron withdrawing group. Whenever you attach an electron withdrawing group to the pi bond, what will happen? These pi bonding electrons move towards the electron withdrawing group or not. Thereby what happens? Electron deficiency will create at this position. If you see the diene, two pi bonds are in alternative mode means this is electron rich center or not. Always electron rich centers want electron deficient centers or not. So if you couple conjugated diene with the dienophile, one should be the electron rich, another should be the electron deficient. Conjugated dienes are electron rich, thereby dienophiles should be electron deficient. That's why what we are doing, to the pi bond we are attaching electron withdrawing group. See this one, to this pi bond ketone, CN group, ester groups, anhydride group, ester group, ketone group. So these kind of dienophiles will interact with the conjugated dienes. See the simple example, 1,3-butadiene combining with the ethylene producing the cyclic product. If you see the mechanism, this mechanism is the example of concerted mechanism. Already we know that mechanism is two types. Ionic mechanism and the concerted mechanism. Formation of the ions are the species, carbocations, carbene ions. Like that we will observe the ionic mechanism. But in case of the concerted mechanism, what happens? We will observe the cyclic transition state. Here the important point is that how can we write the cyclic transition state? That is very much important. See this one. While writing the cyclic transition state, we need to observe how many bonds are involving in the breaking and how many bonds are involving in the making. That we need to observe and put the dot lines between those atoms. See this. Here these pi bonding electrons forming a bond between these two carbons. So dotted line. These pi bonding electrons forming a bond between these two carbons. Dotted lines. These pi bonding electrons moving like and forming pi bond. So dotted lines. These bonding electrons are breaking. Dotted lines. These bonding electrons are also breaking. Dotted lines. In this way we can create the cyclic transition state. Okay. If you see the dienophiles, if you see this one, to the pi bond both the ester groups in the same side. Here opposite side. Cis trans configurations we are observing or not. Thereby there is a chance for the stereochemical products. That is very much important. If you see the first example, Here we have simple conjugated diene, 1,3-butadiene. That 1,3-butadiene is going to combine with the compound enophile, which is in Z configuration or cis configuration. What the people are saying, whenever the dienophile which is in the cis or Z configuration, the groups will be in the same side. It means syn product will be the major product, trans product will be the minor product. In case to the same conjugated diene, if the olefin which is in the E configuration or the trans configuration, then these groups should be opposite to each other. Opposite means anti-configuration. This phenomena you need to remember. Okay, this is the first case. Whenever there is a chance for the olefin or the enophile which is in either cis form or the trans form, which is in the cis form, the groups will become in the same side, which is in the trans form, the groups will be in opposite position. The second condition is that the enophile is stable, there is no change, but if you put the substituents at the conjugated diene, at the terminal position, if the groups are opposite to each other, then we will come up with E configurations or not. Simply if the groups are opposite to each other, in the final product, the groups will be on the same side, syn product will be formed. Remember that. If the substituted groups are opposite to each other, in conjugated diene, in product, those groups will be on the same side. Syn product will be observed. Otherwise, if the groups are in the same direction, in the product, the groups will be in the opposite direction. Anti-product will be formed. So these are the very much important relations which we need to observe. The remaining examples are simple examples. In case of this one, this conjugated system involved with this pi bonded system, thereby we're coming up with a bicyclic compound. Here also bicyclic, here also bicyclic. See, here the olefin is trans or not, that's why trans. That we need to observe. So in this way, we can identify the different products formation during the Diels-Alder reaction. Okay, thank you very much.